All right, my macro friends, what happens when you get hit with two shocks at the same time? Take a look at one of our macro models. And what we're going to talk about is intuitive and empirical of what happens when you get hit with a labor market shock and a government spending shock. To do both of them, we need a nice big complicated model or four equation model with the IS, MP, PC, and OL for Oken's law. We're going to combine all those. We'll do it mainly intuitively. You should be able to actually work on this analytically as well, meaning pen and paper, but we'll focus on the empirical. So suppose the government institutes a new regulatory change, OSHA, Occupational Safety and Health Admin. They enforce a cap on the number of hours each employee may work. Think of it like truckers, right? They're cutting back on the number of hours. Maybe they do that with the impetus to reduce the unemployment rate, right? We need to ship the same amount. We need to have the same number of hours of rubber on the road. But if each worker can be in the cab fewer hours, we must need to employ more of them. Not saying that's true. Maybe that's a thought process. So we need to enforce that. We're going to spend $500 million. Uh, our numbers are huge, right? Our numbers are going to be in billions and trillions. So I'll just call that zero point 0.5 just for now. We're going to have some calibrations. I said calibrations. It sounds like calibri. Column B, all right. Parameters, shocks, exogenous variables, and for my students, I'm giving you free of charge. We pay tuition. Um, all these equilibria. Okay, so in addition to that, I want you to think about two new calibrations. One is inflation expectations and how they are formed, adaptive. Um, Think about the way in which the adaptive expectations work. Very often, what we're saying is, my best guess of inflation tomorrow, when I'm making it today, is whatever it was yesterday. Right? We said that, and human beings can be slow in that adaptation. I want to tweak that a little bit. My best guess of inflation tomorrow is going to be wherever my guess was yesterday. Plus, I'm going to tweak it a little bit. What I'm going to say is, I know that I have to hit to some long run level, some star level, pi star 2%. So what I'm going to do is say, well, the gap between where I thought it was going to be and where it should be, half of that gap is going to close. You can think about all sorts of ways to tweak that. Maybe it's not based on inflation expectation yesterday, but the actual inflation yesterday. And you can think about lots of sociological reasons why people's expectations may be formed like that. That's number one. Number two, suppose not every dollar of government spending is built the same. $1 government spending on defense R&D maybe could be more powerful in terms of its impact on economic activity than perhaps on health and human services or something like this. Now, I'm not saying that's true, but in my calibration, I'm just going to use it with multipliers. I'm going to split up G into two chunks, non-defense and defense. And I'm going to say that the multiplier within that epsilon IS of the defense is zero point 0.8, non-defense zero point 0.5. So you can see which one is more powerful and the relative magnitude. With that, I want you to answer a bevy of questions. Here's just three. One, what's the size of the reduced form epsilon IS shock 2? What's the size of the epsilon OL shock 3, G, C, and I? And in fact, this should even be reduced form um, as opposed to the structural values. Structural. Remember the differences between them? Reduced form, that's the CIGNX, that's all the structural stuff. That's the nitty-gritty. Reduced form is just the models, endogenous variables, the Y, pi, R, UR. Those four endogenous variables. That Y is total economic activity. So the structural splits that up into its individual elements. And one way in which the structural differs from that reduced form. Now, I've got all those calibrations. For you to work on this, what I recommend you do is you take this copy and make a new tab. YouTube magic, I already did that for you here, but I want you to work on it on your own. So let me work down column B, column C, and then I'll go through the rest. So that looks the same as before. That looks the same as before. This looks the same as before. And these are the nice presents I made for you. All those beautiful formulas based upon the four equation systems equilibrium. All that's the reduced form. Then what I did was I had some structural variables. We can even, if we want, no, we could color a bunch of these in blue because I gave them to you. That rhymes. Not supposed to rhyme. These are in blue. That's in blue. That's in blue because I gave them to you. Consumption, we know that it's the C0 plus C1 disposable income minus C2R. And we talked about the reasons why it has that structure. We know I0 or I1 minus I2R, right? Increase in the interest rate, reduction in home purchases and automobile purchases. We're going to take NX as purely exogenous, add those all up, and you get economic activity 208.94. It does not match the economic activity from my reduced form model. How do I fix that? I just take a little scale, go back up 20, right? Take the scaling. And if you want to see it a little bit differently, take the structural model, scale it, and you get 100.05, 100.05, right? So that's all the purpose of the structural reduced form scaling factor was. We talked about that previously. All right, now let's go to period T. All the same. We'll talk about that in a moment, in a moment, in a moment, in a moment. Same as before, same as before, same as before. Not the same as before. Double click. B17. So that's yesterday's inflation expectation. 0.5. B15 minus B17. Remember I was talking about inflation expectations being based upon where I thought they were plus closing half the gap. And that's what this thing here is doing. It's closing half that gap between the two. Now, the amazing thing with this is that even if there's no shocks, that impetus towards an increase in inflation, right? We're at 1.75, we're supposed to be at 2. We're going to get closer and closer to closing that gap, even without any shocks. If I turn that to a 0 and that to 0, which I'll show you how I got those numbers in a moment, there still would be a movement in inflation expectations and thereby the AS curve and thereby output, equilibrium, and the rest. So any policies have to kind of confront that, fight that. Be aware of that. All right, so let's keep on going down. Those are the same formulas as before. We'll touch on this in a second. And now, that's the same. In fact, just to illustrate the point a little bit more carefully, the same, the same, the same, the same. This is different. Where does this come from? That's 0.5. Okay, so where is that coming from? That's from the story. Remember, they're spending an extra 50 cents, $500 million. All these, let me again just to harp on the point a little bit more carefully. All that's the same. All that's the same. All that's the same. So the only thing that's changing is the fact that we're spending an extra $500 million in non-defense. And as a result of that, this goes up by 50 cents, which is 0.025% increase. Okay, so then how do I include this structural piece into my, I can even write up here, reduced form? How do I include it into there? Well, that's where epsilon IS comes in. 3 things in there to form the epsilon IS. This is not new, but I wanted to show you in this setup. So let's do this. Let me scroll down. Remember C33, D34, B49, those 3 pieces. All of that is what generates epsilon IS at time period T. Let's start with the D34. Okay, so how much should the IS shock be? Well, it went up by 50 cents, so it should go, epsilon IS should go up by 50 cents. I think that's probably the most intuitive. Make sure you're locked in to remembering what the IS curve means. It's all the demand for goods and services. The epsilon IS is anything that's going to compel that demand for goods and services other than what's connected to the endogenous variables, non-defense spending in this particular case. Okay, so that's the first component in the D34. What about the C33? Well, I made the comment before. You saw in the instructions in that orange that not every dollar of government spending is created the same. So when I'm going to introduce that 50 cents into the IS curve, I have to distinguish between defense and non-defense types of government spending. G2 is going to be this multiplier on top of it. $1 increase in non-defense spending is going to impact economic activity on through the IS curve, zero point 0.5, whereas $1 increase in defense spending would increase it by zero point 0.8. That's seen by the 0.80 in cell 3, C31. Now, just keep in mind, impacting the IS curve by that amount is a close cousin, but not identical to impacting equilibrium y by that amount. For that, we would go back to the model derivations up on the Market Observatory website. Take a look. You would see YEQ. Look for epsilon IS, and we could actually break that up. We could write epsilon IS into two chunks, a defense piece and a non-defense piece, and they would have little G1, little G2 inside of there. So when you take that partial derivative, you're going to have each one of those as a multiplier. Right, so I said in order to get to the epsilon IS, there was three pieces. The initial amount of change in spending, sensible. The multiplier hit because of the productivity gains, etc. And then it's the B49. That is because structural did not equal reduced form in our empirical model, so we shrink it. And we've done that one before as well. Now those three pieces are written for you right there. Feel free to pause and take a look. If you're in my class, you're going to get all this. It goes through the scaling, multipliers, and reduced form to structural that we just talked about. I just talked to you about. Okay. All right. So that's not the end of it, though. That tells me how much epsilon IS is going to move, but how much is epsilon OL going to move? That's just a number. Where'd that number come from? Well, this gets to chunk right here. If you remember, what we were saying was the impetus from the government for instituting this OSHA regulation was to reduce unemployment by how much? Remember? 5%. All right, so we're going to call that a target, which means we're going to put that in blue. And I computed the changes and the percent changes across each of these things. And I set up a target and I set up a squared error and I sum that. Really, you don't need the G26. If you've been working on the problems with me, we know very often we have multiple criterion of the endogenous variables, and then we sum those squared errors. So the Excel structural form makes sense if you have that basis, but we could have just targeted that bad boy right there. Now, how do I make sure that I'm tuning epsilon OL just enough so that I'm hitting my target? Well, let's go intuitively first. Epsilon OL was inside of Oken's law. Oken's law was the relationship between output and unemployment. And what we were thinking about was a curve, and that curve was going to have a UR and a Y. And what we want to say is that downward sloping, remember, and what we wanted to say was we're going to have a lower unemployment rate. For any given level of output, maybe the trucking example, for the number of hours that the rubber's on the road, we're going to have a lower unemployment rate, which means that it's going to be a movement. Like some OSHA shock is going to cause this to come down, so we have a lower unemployment rate. So if we're starting to think about the change in the curve to bring it down, the intercept of that line must be coming down, so we know the epsilon OL negative. So we have the direction. If you're trying to work your way through one of these problems for exam, analytical practice, whatever it is, or if you're using this type of model out of the field, work on the graphs first, work on the analytical, work on your intuition first. We know that this must be reducing the unemployment rate for any given level of output, hence epsilon OL negative. I don't know the amount from that intuitive story, though. How do I find the amount? This is where my friend the solver comes. All right. So G26 What is that? That's the target for the sum of squared errors. Take a look at the unemployment rate from my model. It's percentage change. Take a look at my target for the unemployment rate, minus 5% for that change. Take the difference between them, square them, and that's going to be in G26. What do I want to change? By changing variable cells, C11. So I'm going to move the epsilon OL shock. In which direction? Until I'm minimizing, see right there, minimizing G26. And I'm not going to put any other constraints on there. We could think about doing that, but we're not going to put any other constraints. When I did that, you should get something that looks like this. Boom. I got minus zero point 0.2, and look at that. That gave me exactly 5%, dropping an unemployment rate from 4 to 3.8. That's a 20 basis points drop. That's a 5% drop off of the 400 basis point initial level and hit my target. All right. So that means then that the new OSHA requirements in my reduced form model were equivalent to an OL shock of minus zero point 0.2. To enforce that, it was an IS shock of 0.12. Let's see what that did to overall economic activity. It increased economic activity. It lowered the unemployment rate. It increased inflation and increased interest rates quite dramatically, in fact. Now, that's depending upon our calibration. So we have two shocks. Now, that's the thing. But when you were getting hit with two shocks, remember our cycle of activity? Well, we got Y, U, R, pi, and R in this cycle, and we usually start wherever it's getting hit, and then it funnels through, but we're getting hit in two pieces. So the intuition gets more difficult. That's one of the reasons why doing the empirical is so helpful, because it can assist you with figuring out the net impact. We can get a little bit of the intuition in there, though, right? I mean, all right, so if we get lower unemployment rates, if there's lower unemployment rates, that means that there's probably going to be more people working. And a Phillips curve would tell us that there's more inflation, right? Well, we got that. And a monetary policy rule would tell us if there's more inflation, there's higher interest rates. We got that. And if we got higher interest rates, oh boy, well, that would usually mean less economic activity. But don't forget, this wasn't the only shock. We also had that epsilon IS shock, and that's what helped to compel some economic activity to rise. Now, which one's winning? The deleterious effect of an increase in R or the stimulative effect of an increase in G through the IS curve? Well, that's dependent upon whatever is the size of the shocks and your calibration, not only here, not only there, but also within your reduced form model and your multipliers. Okay, so that's the reduced form setup. Let's take a look at those structural pieces. We know that government spending went up by that amount. That was entirely exogenous. Consumption went up. And in fact, we could do that. Consumption went up. Why did consumption go up? Well, economic activity went up. So that makes sense. But we did probably have a little bit of a decline because of the increase in the interest rate. And don't forget, this is connected to that increase in the interest rate. So had it not been for that, if C2 was zero, perhaps, then economic activity would have driven consumption to be even higher. We have a decline in economic activity, pardon me, in the investment. Let's make that look nice and pretty. A decline in investment. Why is that? Because the interest rate went up. No change in net exports. Why is that? Because we said it was exogenous. And we have a change in economic activity, whether measured through the structural or through the reduced form. All right, my friends, hope that helps.